CANopen organized series of webinars within the year with various topics of the interest. Some of them are addressed or assigned at the time before certain fairs and events of ours. Some are just independent from this. This webinar is specially designed for the upcoming Interlift exhibition here in Nuremberg. Since CANopen has already 20 years of history with CANopen interface development for lift applications, we thought it would be very nice to preliminary provide some details, updates, what is going on, especially in our booth and with our working group that develops specification for CANopen Lift. Before we go across all the things, first of all, welcome all to our webinar. Thank you that you came and watched this live event. Of course, every time later, if you need to concentrate on a specific topic, you may go to our YouTube channel where this video of our webinar will be posted. Few words about myself. I'm working for CANopen already a long time, comparably, supervising several technical groups, including, of course, this for CANopen Lift and also subparts for CAN-based technologies. That is the main topic of CAN in automation organization and a company. Besides that, I'm also testing devices for their compliance, conformance to CANopen, to basic CANopen protocols, so we can satisfy the need of industrial development. Before we go further, just a brief overview of what is expected in here. There will be a couple of slides with introduction of CANopen for those who know about us, maybe want to know something additionally or never knew and are pleased to hear this from us. Couple slides, then we have introduction in CANopen Lift, also for the people who may already involved or may look at CANopen and into CANopen Lift for the first time. And then the last smaller part will be about some updates. We have updates, changes, what is new in CANopen Lift world, let's say. So CANopen was founded 10 years after development of CAN interface, controller area network for automotive. Basically, the idea was to have unified communication system beside the unified cabling across cars. 10 years after this development, the reliability of CAN led to assumption and led to much more interest of using CAN in industrial applications, so that we started. By that time, a couple of years later, the working group CANopen Lift started as well. So the idea of organization was to provide the information that was lacked or not available for very specific car industry, automotive industry. So independent organization was necessary to provide some product marketing information on CAN-based technologies and how to work with them. You can find us at the only location. We don't have any affiliates around the world. Although we go to the exhibition, we know some people go in every part of the world. If it is needed on fairs, some special technical days, we call it, visiting companies or visiting countries at certain time intervals and providing this information, doing some interesting presentation, industry related and so on. For the contact information, you know we are located in Germany, in Nuremberg. We have those phone numbers and an email address where you could contact us if you need some general information about the organization and what is CANopen. You may find this also on our website down below on this page. So next one, I'll try to do this stuff much more quickly so we can concentrate on more technical related aspects of the topic. The company is also membership based, so our members from the beginning are staying with us. 8 members at the very beginning, 1992, they are still members, but now we are grown far more. The interest in general and CAN-based technology reflects in these numbers. Exactly knowing how many of the CANopen Lift we can only do within CAN automation. So this comes in a slide a little bit later. So we offer various services beyond the general marketing, product, and technical related information. We work on specification. We create working groups that respond to industrial requests, to our requests from our members, with ready developed specification together with these groups, which consist of our members. We go and provide information on affairs, technology days, international CAN conference on one hand. On the other hand, we provide this as marketing information for our newsletter and provide this in certain areas for our technical related members who design the devices and so on. Besides that, we offer also testing of the devices, some education, as webinars are more likely seminars, a full day training on CANopen. This training, you can also find a comparable training within companies which affiliated with us. There are only few companies offering this, but nevertheless, you get all information you needed either from us or those companies. The unique point or point of view of ours that we are working with our members and provide specific details, specific information, offering visitation on behalf of our members on affairs. And so the company is actually separated in 2 different acting bodies. One of these addressing marketing opportunities. So we have marketing groups, another one addressing technical groups. Within marketing groups, on behalf of our members, we go to the exhibition. And if we talk about CANopen Lift, then Interlift is the next exhibition where we go. In the past, we had on the right side of the picture, you see some mounted panels with devices as a blocks. In a modern time, we don't have this one, but at a certain time, every company has designed their own much smaller block of the devices they can demonstrate on such an exhibition. Additionally, we offer panels where you can put very small, simple, even dummy based module, dummy looped module without content, but you can just say, okay, this is our device and this is what we can post on such an exhibition. So people flowing across the halls can see the device, say, okay, that is a part of CANopen Lift and I need comparable device. Okay, I contact this company. So again, we organize technology days, webinars, other events on behalf of our members, visit fairs, go to the fairs, present devices of our advertisement from our members and so on, make presentation on conferences to promote new technology in a very specific or existing technology like CANopen Lift in a very specific market. On the other hand, we have also technical groups which are organized and structured, as you see in this slide. These groups maintain existing specification, develop new, together with our members in very specific application fields. Just briefly for you to understand our operational structure of technical groups, there is overseer committee that decides in which direction CANopen automation goes in every market. When they decide this, when they have a special, specific groups for very specific part of industry, like lift control or construction machinery, and this one you find under profiles here in the picture. This is one of many profiles. Since we have now many CAN technologies, 3 at least, that is necessary to structure them by the technology, because profiles in itself, a specification may be technology independent. So you can also design lift even in J1939 way, but we're not that far and we have not requested, it's just an example of it. But regularly we have most profiles designed for our CAN-based CANopen CC called here is a classic CANopen technology. All specifications are designed for that in the first place. Nowadays, we have extension, we have new technologies far superior regarding data transfer, data speed, called CANFT. And for that, we have adopted another application layer called CANopen FT. Fortunately, for us, we don't need to straight go with the lift to CANopen FT because CANopen, classic CANopen satisfies for the moment the needs. But if the need is there, we can make a transfer in that. Beyond profiles, several topics like high availability, safety, security play a bigger role in industrial applications. So we had to separate them in special areas. This means that what we design for availability and safety and security can be integrated in each and every profile. But we talk about this in details later. A couple more slides, and then we are at marketing opportunities for the Interlift. So this one is general membership, has certain advantages for users. You have a right to participate in a working group and can introduce your function and discuss with the others in this group how to integrate this function into the profile. That's the main advantage in there. Besides, you have access to all subsidiary additional specifications around development of each single components, either this is lift or some other thing in there. That is the way you could get it. And of course, participation in the Plugfest, especially regarding Lift Plugfest, we'll talk about this a little bit later, is given in there. For non-members, participation Plugfest is not really available. Maybe once as a guest, it is possible, but for regular base where you need to test your devices will be a little difficult, and we are not offering it. So a couple of slides on lift-related marketing we have. Very soon we have an exhibition. We have within the CAN automation regularly Plugfest. This is interoperability tests for CANopen. CANopen component and host controllers, so we can check out if the device implemented correctly, if the devices behave correctly in the network, especially in a real lift network. We have built in the past so-called reference network that we can use and check out all devices within it if they satisfy and can be integrated in the network. Additionally, we offer further plugfests, but this is beyond CANopen Lift. This is for data link layer and physical layer for testing new technologies. As I said, we have 3 CAN technologies. We have done already several such plugfests where we tested and made them fixed and ready for the future application. Interlift is a little bit more than a week. You will find us at Hall 3 here in Nuremberg. The exhibition moved from Augsburg to Nuremberg. So we can call in this year at least the exhibition our house exhibition, let's say. So we will be there. On our booth, we're presenting mostly general information about CANopen Lift. You can also get CANopen Lift poster, some lift brochures, get some information on CAN-based technologies, discuss with our technical experts, especially also with me. I will be a couple of days in the exhibition. Then there is also an opportunity, a marketing opportunity for you if you would like to make some advertisements for your product. If you develop lift product, that will be an opportunity in the Interlift to visit us and ask for advertisement, or you can write us for the next time. We have also media within CAN Automation, such as product guide, where we put the advertisement about certain products, certain directions, certain industries in our online website. So, CANopen Lift poster looks like this. You will get this in much larger size. As I said at the beginning, we go through several slides, going a little bit inside what is lift profile. When you start development, what you should know about CANopen Lift. What is CANopen? If you know what is CANopen, then the lift is the kind of application profile for CANopen based systems. And if you start development, you state before the requirements, how large should your application be? So basically, for satisfy most of the needs, we suggested we can have up to 8 lift applications. This is not necessarily means that is only one lift car inside. It could be more. We can have always also a group of lifts controlled by the one single lift application, but would be a little bit difficult. So you have to scale up and down your requirements and your network to get fit into possible scenarios for you. So for the moment, we have up to 250 and change floors. It could be much smaller. Typically, application is smaller than this, maybe even larger. For that case, then you need maybe a couple of applications, maybe some kind of gateway which shares with multiple times of the same system. I pictured this on this slide as fit into a house, but this was the basic idea. So we make it generically for as much as possible application function available for such one. So there is a specification, of course, behind, and in the specification, it is designed. You have CANopen device, there are plenty components for lift. You have host controller, which lift controller controls all these drives in there. a single drive called inverter, maybe several drives, maybe several lift applications, how they interact within each other. And this is typical, so easy and simple representation of lift network in here, where you can look into this and see what is about a lift parts you will need in every system, more or less. There are several concepts we need to consider in this one. We are talking about software, not only hardware, but mostly software. CANopen is software in this case. Then you need to interact, it's communication software, of course. You need to interact between different parts of the device over CAN networks. So you have physical devices like lift controller, then the car itself, lift car itself, car drive, then it is also door within, and that is the question if they are physical components, or maybe, or most rather is the case, that you need to interact between various components and collect the data and send the data also to various physical devices. But that will be too heavy, and then each physical device may have further components. Beside the case, you want to have some receiving part for the very same entity, which we call virtual device. This is a piece of software. Then just to break it into very small pieces, imagine lift controller may have kind of call management. So we have call controller. It may also control drives or drive itself. Then it can also control the door, internal, out, and external door of the car itself. And there could be also control management and manage the input-output panel when you press the button, if lifts goes up from outside or from within the car. So for that case, we said we have those pieces as physical devices, but they may have software entities we call virtual devices. So virtual devices then in this case will be called, as you can see in this slide on the right side, we have a list of virtual device functionalities such as call controller, input panel, door controller, drive controller, car drive unit. So plenty of those. They are fit also in several of those in physical devices, but they could be also independent software entities in there. Where you can find them, if you purchase as a system designer would like to assemble your lift device, there are several CANopen parameters you need to look into just to get information. What is the component I've purchased and which components I do need. From the structures, you can see the lower 15 bytes describe the number 417. This is number of CANopen Lift specification. We come up with further slides to it. So this object, by reading of this object, you know this is about lift profile. Then you know this component has certain software entity as a virtual device, one of the lift parts you need in your system. This is located in the upper 8 or in upper byte as virtual device code. On the right side, you have the most actual table with the list of these values. Of course, this is a nice case. You have one device, you know what is a virtual device inside. But assuming we have, again, such more complex system even, where you have multiple virtual devices located in a very same physical box, like here, a simple one. A car door may have car door unit control, and also light barrier for the doors to prevent the doors to close or open if something is entered this area. So we have already 2 virtual devices in one physical device, which is car door. That means in this case, I cannot put only one, I need 2 of those. So we have virtual device car door unit, and we have a virtual device light barrier unit. What do you do if you need 2 of those? So we thought about this as well. For this case, the value of the upper byte is set for 0 for multiple virtual devices. And then we go to additional object providing information about support. There you can define up to 250 plus virtual devices allocating within this physical device. This is good to know for the system. This is where you find the information about your whole system, which physical part have what virtual devices, and do you have all you need to operate your network. Let's just briefly a few things structuring or architecture of the software for CANopen Lift application. As we said, we can fit up to 8 applications, 8 independent applications, control up to 8 lifts, or 8 group of lifts. So kind of. And then if you know a thing or two about CANopen, then you know that CANopen offers, beside the protocol stack for communication, also a database with parameters where you describe application parameters, communication parameters, and manufacturer specific, and some intermediary data you need in your application software. This data bun is structured by index, so-called index and subindex, 16-bit hexadecimal number, and subindex is 8-bit or byte long hexadecimal number. Together, they indicate or represent unique reference to whatever parameter you need. To make the structure, we assign the numbers, so the 6,000 up until 9,000 3 times 3F is the area for CANopen device and application profile parameters. So in this slide, you can see if you have typically you use with a very simple system, just lift control application, one lift control application, the area and range of these parameters. I said again, this is profile related application parameters. Then you see within this application parameter range, you have sub-ranges where you put parameters defining behavior of each single virtual device you have in your application. Second one is communication. When you have these parameters, configure the system and so on, you need to exchange data, get the data, position where the car should move on, and so on. What is the status of the lift in general? What is the status of doors? Nothing stays between the doors. Door can be closed and lift can drive up. So for that, you have process data object, a communication protocol where you can transmit CAN-based way the data across the CANopen Lift network. So here's just an example for your very small and simple application. It could be also a complex one, but for a small one which covers only one application, I've just compiled some videos that I used in their area. And on the right side of the slides, you see what parameters are coming within these protocols. This is kind of status is transmitted, position value, light barrier status. Is nothing inside, the door can be closed, some such things whatsoever. And then in the second slide, you can see how this real life is transmitted and how you are mapping these parameters which identifiers are assigned into there. And this is the right point, I think, to say that in contrast to generic CANopen application, even to a device profile, an application fit profile such as CANopen Lift means that PDO and identifier are fixed, assigned to allow even up to plug-and-play system, fully pre-configured one. So basically, it should work like this. You purchase a component for your network, assemble them together, turn it on, configure, and they find the same with exactly these CAN IDs and exactly these PDO numbers, and you find exactly these parameters, as you see in the second table, like position unit with position value within it. You will find exactly in these places the data you expect. That's the idea behind the fully configured PDO communication for an application profile. So here is just a brief, let's say, some summary and specifics and maybe some issues you have to confront if you start development this. And after these slides, we go to talk about more about what is update comparison to the previous versions of specification. What are the specification? What is the specification? What is these parts? Is there something else like guideline how to do things? Comes next. But here you see specifics. You have object 1000, index to 1000 device type. You know exactly if it has a physical device component, any virtual entity inside which interact with the others, several of those, then you need additionally object 6000. You can control error behavior of the whole network with only one parameter, 1029, meaning the network should always be on in certain environments. Then you can configure this in this object. Or maybe the control device, Lift controller, should restart the network, stop the network, manage it if some malfunction occurs. And especially if it's critical malfunction, a network has to be turned down for maintenance. Additional global network-wide information on what is going on, what is happening in there, what went wrong, is coming with emergency message. This is typically a feature of CANopen itself. In CANopen Lift, it is designed additionally with certain further information, which you can find in specification, that certain cases related for lift facility are covered by these messages additionally. So you have pre-configured, or let's say can we have a fully configured PDO communication for even up to 8 independent lift applications, the 8 lifts or 8 groups of lifts, and all PDOs are assigned. So all you need just to start a configuration software, and it is just checks out if the mapping parameters PDO is configured as it is expected, and that's it. So no different additional overhead for configurations in this case. Standardized application parameters. So you have the range only for lift itself, which identical from each lift manufacturer to another. Additionally, you may have also your specific functionality. You can store those in manufacturer-specific range, 2000 to 5000 triple F. In this case, plenty of space for your own functionality, but be aware these parameters are no longer known by the other manufacturers and not standardized. So in configuration, you need to provide information on that to your prospective system designer, customer system designer, so he knows where to find this information as well. Beyond this, in a recent version that will be released very soon, I hope, we have harmonized definitions we had in there. You have a big network already of lift, multiple components, maybe several subnetworks of CANopen connected to the lift controller or something. And you would like to also to interact between the virtual devices. How do you do so? For that reason, there are PDO bridges, gateways designed to cross the gap. So you don't need to replicate every time object dictionary for every single virtual device and design it somehow, but you can just copy, just hold exact image of it inside such kind of gateway, bridge, PDO bridge and gateway, so you can reflect it and read the data and store the data in there. So every kind of entity can access other similar entities and get this information from there. Additionally, we have secondary STO channel. It was actually possible, but it was not standardized, defined by default in there. Now we do this. There is also several things you need to know. You need additional identifier for those, but you find this in the specification as well. We have harmonized, improved, and make this more understandable, this interlock mechanism to restrict access to the parameters from outside to prevent destroy existing configuration and so on, or access parameters which are not available or functionality that is not available for certain access rights. Imagine you have several management levels, super user, standardized user, and just technician. You would require to kind of restrict access to certain elements of your design to them, and so on. For this case, this local and local parameters, as well as enable and disable standardized functionality, is designed in there. So we made it more understandable how to do so. Basically, power saving, power management, power measurement is now provided, is supported. You have just to learn and manage how to do so, and specifically look into functionality you would like to have there. There is also safety security aspect, which we will talk about later, but in additional specially designed slide for that. For the moment, we went across just basic concepts of the lift application. What do you need for that? What you design now, where you find this all information. So in a working group CANopen Lift, we've designed specification number 417. We recently are in the release of the next version for implementation. It's not yet. Hope we do this before the interlift, but I'm not sure of this. It consists of 4 parts. In the first one, you find general definitions and also structures, possible network designs for your lift application. You find Node ID assignments is CANopen unique device addressing. Then you find out node ID assignments not only for a single lift application, but a group of lifts, which is very important. Some key things about bootloader, accessing of various functionalities, indication of certain text patterns, and so on. You will find this also in part 1. Second is virtual device definitions. You find parameters assignment for each single virtual device, and you find also PDO mapping for each single virtual device. Part 3, you have PDO mapping. In contrast to part 2, where it's just a list which PDOs are used. In part 3, you have completely list of PDOs with their parameters where it is all mapped. Finally, in a part 4, you have your application parameter specification in there. Then you know which parameters are mandatory for lift, which one you can skip, which one you should use if you design certain functionality. Additionally, to help you out to design things, we have in CiA 8.14 part, we have 2 parts now. A part bootloader is already released with version 1. The additional lift power supply units, or not interruptible or non-interruptible power supply, is in design, will be released in the first version. How to you will find in there, but the parameters are always designed in the basic specification 4.17. This specification is available at CANautomation. As a non-member, you can just take a look and go over our website, download the public version, which is a little bit outdated, while we keep backward compatibility to cover much bigger market segment and allow people to design devices which are future-proof as well. So specification with the newest version and a DSP released is only available now for our members. We sold specification series in the past, but we have closed this thing now to get the recent work draft or specification for implementation as draft specification proposal. You have to become CiA member. So now then, the last part, what is update compared to the previous webinar I had last year or a couple of years before. There are only a few features. I'll go through them. So the first one is that CANopen Lift become very mighty. We have these ranges for 8 devices, for 8 physical devices. Within each one is sub-ranges for virtual devices. Now the ranges for virtual devices were too wide and bright, so we decided a little to reduce this to the sense for minimal range, so we still can have for our parameters. So we increase the parameter content for the future parameters, so we'll have some. So there's one thing. Another most important is that MPDOs are used in 4.17 are not entirely compatible to MPDO concept defined in our basic specification CiA 3.0.1. So for you to know, if you design those, there are destination, DIAM, destination, access MPDO, and source MPDO. They have both different. The idea behind one and the other is not only destination, it's described only one side, not the reception side. First one doesn't need anything large. Destination one requires actually just the address where it is located in the local object dictionary of the receiving device, nothing else. Where the source MPDO needs the whole list from where in a receiving part you know where the data is originated. So the counterpart is not described by those. There is also to every one to destination address mode and source address mode. The counterpart will be different. So they are not destination mode and source mode. They are not sending and receiving part of the very same. They're completely different. Each of them has its own counterpart. It is different in CANopen Lift. They used destination as a counterpart to source address mode and vice versa. That is important thing that you need to know. We harmonized this and said, okay, this is not entirely CANopen idea, but it is already for 20 years. So we have to update or adopt this to the existing situation and offer the most interoperability is available in there. Next one is, of course, interesting part, cybersecurity, cyber resilience. We have already two or three live meetings where we discuss this. We regularly meet to meetings at least twice in a year, but we have multiple meetings, online meetings in between, web-based meetings in between. So we discussed the cybersecurity because there is cyber resilience and cybersecurity acts already, especially in Europe, already active. They are not defined or how to do things, but just cover up what every manufacturer has to do and evaluate in regard of security in his device. For that reason, we have a paper of our chairman of this working group for lift control. Very nice, interesting and valuable feedback article in Lift magazine, Lift journal, describing what is needed. So assessment shows there is no big deal for the moment, for now, for lift, because it's actually enclosed in the shaft and the access is available only with the real physical key. If the person accesses the key, you can of course access the whole stuff and there is nothing that can help against it. So for the moment, as the recommendation, also from Cybersecurity Act and so on, every manufacturer and operator does his own assessment of security of the elevator system. In Europe, there is a special requirement, this TRBS. Part 1, for the other countries, there's also national, their local national cybersecurity requirement assessments available. So each single manufacturer has to do this on itself, evaluate how much is his system vulnerable and what he has to do about it. So for the moment, we talk, but have no certain way how to solve this. On the other hand, beyond CANopen Lift, we work on generic cybersecurity, cyber resilience concept within our highly cybersecurity group. But the concept is somewhere at the very beginning because nobody really knows what has to be done in there. There are not certain special requirements which shall be fulfilled. For the moment, it's just more things are recommendations or suggestions to make assessments, nothing of that, but we work on this. Within CANopen Lift, for the moment, we are evaluating the stuff. So, couple of things, two of those. Bootloader. There is also, of course, CANopen bootloader is defined very generically. Actually, it's not defined anything. It is just a bunch of things you could put together and have your very manufacturer-specific bootloader functionality, whatever. We have already application-specific because generic is a nice thing, but application has its own requirements. So I have to be there is no generic, basically no generic bootloader things. Every application has to be fit its bootloader to its requirements. And nevertheless, we have designed in specification 702 recently more a generic approach to this, to the bootloader design. Of course, this approach could be taken and improved and make it deep with additional requirements from the application itself and will be fit into each specific application. But the Lift group decided to handle this simple way with original, very generic one, pick up some parameters, design some functionalities as it was from the very beginning. Hopefully, at a certain point, it will be also combined with cybersecurity considerations. So we will have and think about this. For the moment, it remains as it is. And here also, similar to this destination address mode, different handling in CANopen Lift comparison to rest of CANopen world. Parameters for program control for application for bootloader, this 1F50, 1F51, are not always, let's say, are not defined in deep by generic CANopen specification for that. Therefore, also Lift has its own flexibility, so you may find sometimes incompatible solutions from outside of CANopen Lift, from other profiles of CANopen. So don't be afraid. In case of CANopen, then the objects are handled also a little bit differently. But this is what you know if you come to our Plugfest and see how things working. Here's just an example how we have other thing like redundancy concept, which might also be interesting for a lift application, creating redundant lift system for special cases, special applications. We have also redundancy concept already. This is a new one where we set the key things, one application layer, one network layer with so-called DMR function, management function of this so-called dual modular redundant CAN. Has, in contrast to our previous specification, also 302 something we had in the past, very generic one. Now this more advanced version in 701 specification. It is also ready to go. Now the question is, we discussed this, but Lift has no specific redundancy concept and relies on their specific ideas. Basically, it's manufacturer specific how you design it. But there will be just a thought to consider using this dual modular redundancy concept of this, helping out to simplify redundancy implementation. Finally, we have also this power supply, which you see on the pictures, just basic, very generically, showing you, okay, so if you have the main power, if the power is cut, nothing works, but at least the key functionality of Lift working, the door become open only, of course, if you are in a proper floor or in a floor where a passenger can go out or the cargo can be brought out without damaging it. That's the idea. And such a power supply can be, of course, provided using renewable energy sources as well. That doesn't, of course, completely eliminate the main power supply, but in certain cases helps or has as an auxiliary supply for the lift network. So far, so good about this stuff. Then is this final slide about summary. Then, what do we have shortly before Interlift for the moment? So CANopen Lift is alive and kicking. We have about 50 companies or something that are working with us, that are our members and working, developing actively, some of them actively participating in meetings, deciding, adding new functions, and so on. We have specification. It's constantly maintained, added new functionality, implementation, new release for implementation is pending. Soon we get it. So we harmonized specific definitions of functionality for interaction between the virtual devices. We have secondary STO channel. Secondary STO channel allows basically here, in this case, access device data, and this entity which access this device is not necessarily a manager. So it could be any device which needs to access to any other lift device. That's the idea behind it. Lock and lock mechanism for protection of configuration of the device is improved. The description is improved so you can better understand. Power management, measurement, saving is all under one cover. One thing that was not mentioned in there, we have also fixed initially defined power position supervising unit. Now it is fit for everything. Is after multiple testings and improvements, it fits implementation, works as expected, and serves as a safety mechanism for the lift. It has no features of CANopen safety whatsoever, because the group wanted their specific stuff. And of course, it is certified, can be certified, and now it is ready to be certified without any issues whatsoever. Finally, we have next things beyond the Interlift, that is Plugfest. You're welcome to join us in the next meeting in December. For that, however, you have to become CiA member. So that is basically all from my side. I wish you a pleasant evening, and we'll meet you at Interlift. Hope you see me at the booth staying there. Then you surely can come and answer your questions. Thank you very much. Thank you for participating in our webinar. Hope you see at other webinars of ours.